Hello, good evening, good afternoon, Assalamu alaikum everyone. Welcome to another session on from GTG MENA. Today we're going to talk about security in Google Cloud. Carrying on from the previous topics that we covered. Last time we talked about networking. Prior to that, we did an introduction to Google Cloud. And we are taking different topics as we go along. So yes, hopefully you will find this beneficial. Hopefully you will learn something today with us. But before we jump into to the content of this session, I'll encourage you to subscribe to the GDG MENA YouTube channel. So the link will be displayed now. So please subscribe to the channel so you will get the news and the latest information about what we be doing in on a monthly basis as part of the GDG MENA program. Thank you for that, and let's basically start. So we will start in talking about the foundation of GCP security. So things that we're going to talk about: the Google Cloud Platform approach to security. We will talk about the shared security model within GCP, threats mitigated by Google Cloud and GCP, and access transparency. So the first of all, we'll start by talking about approach to security, and there are approach to security within Google Cloud. We will move on and talk about the shared security model. How does that affect security between the customer, between users of Google Cloud, and what are the responsibilities for that, and what are responsibilities of the of Google from being a cloud provider, and then what kind of threats that Google mitigate against for you when your system are run on the Google Cloud platform. By default, things that are available for you, don't have to do anything that will help you with the security. And then I will talk a little bit about access transparency and basically how do you know if someone at Google has access to any of your data or any of your projects. So the approach security. So let's start with the first one here, approach security. So Google have been obviously operating as a cloud provider securely in the cloud for, I would say, over 20 years. And that's kind of the saying, security empowers innovation. So if you put security first, then everything should be put in place. Everything kind of work afterwards in a secure manner, reliably. So Google have actually 7 services or 8 services that I mentioned before that are over 1 billion users. You got things like you're watching on YouTube. One of those services that it's actually got 2 billion users from the latest information that I've seen. And that means that Google had to kind of think a lot about security. So if you have that those services that are 1 billion plus for 7 or 8 applications that they need to serve, security needs to be thought of and taken seriously. And of course, we will care about all the services that don't have billion users too, but it's just to let you know that Google really think about security and take it seriously at scale. And so designing for security is something that they do a lot, and it's not an afterthought. So the Google security technical infrastructure, and a lot of companies have lost a lot of money. They lost a lot of goodwill, reputation as well, because of some of security breaches. So every day on the news, we see like big companies that have security breaches. So Google tried to avoid that. So one breach like that could really cost Google enormously. Not to mention that Google do actually care about their customers as well, and how the things like that would impact them. So Google have, like we know, we talked about this before. They've got a global scale infrastructure, very, very robust network, very, very kind of robust infrastructure, and they deploy services. They store data, everything in Google Cloud. Everything is encrypted by default. You don't have to pay for that as an extra service. They have secure communication between services. So we will mention those. We will talk about those, how they are encrypted. And also, they're very careful about what kind of access their employees can have to use the customer's data and cloud data. So this is really a very big deal for Google. And of course, Google Cloud is built on all the security built to all of those services. So we can think of the Google security, think of it as their DNA as such. So here is the security layers that we talked about. It's and the operational security. So you've got internet communication, storage, identity, service providers, service deployment, and the hardware infrastructure. So every of those layers, security is kind of there is a role in there. So that's the fundamental to the infrastructure design, which comes at the bottom there, and they're basically built on all those layers from the ground up. So the goal basically at the end is security in depth, and a lot of times companies and not service providers, and this is something for you to think about as a security when you're dealing with security. So security professionals need to take this from the bottom layer and build the other layers on top of that. So security is thought of at Google at the perimeter of the you can think of a wall, for example. Nobody can get over that wall. That's the aim, or through the fence that you protect in your environment with. But that's only one way to think about security. And really, what we know is eventually we've seen those situations where somebody is likely to break through, to go over that fence, to break that wall. This is whatever you protect in your environment with, and whatever that wall is, there might be a day when someone can get around and access your services. So basically, what happens then, what Google do, and what should you do as a security professional, is to protect all the assets inside that wall as well. So that thing are kind of they should be like in compartments, and when you break through, those compartments should be isolated. So you only maybe breaking through to a single thing, a single box, single compartment, and you can't basically spread across the other compartments. So if a hacker basically breaks in, they won't be able to go to the other services. So defense in depth is a key security item here. So this isolation that will allow that security in depth. So hardware infrastructure. So Google take security like from the bottom up. So from a hardware perspective, they actually design their own servers, their own hardware. So they have security chips built into the boards. So they do care about the physical security of the premises, the data centers. There is really good video on YouTube, talking about another Google products here that is secure. So which is kind of the 6 layers or the 6 points of the of security. So I encourage you just to 6 layers of security of data centers at Google, and you will see how security is taken seriously from in the Google data centers. Then we have service deployment. So Google are very careful about deploying the services, about encryption of inter kind of service communication. Remote procedures called are always encrypted, so they have a lot of controls on the source code, and there's a lot of review of code before it's actually implemented. User identity, that's another one. So they have obviously offer authentication. They have two-factor authentication. So all the employees, they use their accounts with that. And storage services. So everything, like I said, is encrypted by default at rest. So again, they are very careful when the chain of custody of the physical devices. So for example, when disk goes bad, which is a hardware, which sometimes it does, they just don't go about upgrading a disk and don't think about what happens to the old disk. They actually, when it's removed from a data center, it is first wiped out, and then it's physically destroyed. So they are very careful about data that is kept behind. If data is deleted, for example, from storage, it is actually deleted from all the backups, and there is kind of a workflow and a procedure after that. So it does take about 180 days as a procedure to make sure that all the data is deleted. So once a user delete data from the services, they completely lose access to it, but it does exist in the backups, in the things that are replicated and things. And there is a time span that it takes for Google to completely get rid of that information, and that's goes up to 180 days. And then internet communication. So there are kind of intercommunication between the services, which is completely encrypted. Anything that terminates at the load balancers inside Google, it does get encrypted. And then there is things like that will help to mitigate against DDoS attacks at the edge of the network. So again, from that, there is layers of protection that Google have put into the place, and the scale of the Google network will absorb any attack. So so that's one of the capabilities and one of the benefits of having a global network like Google's, which they own, that we talked about during the networking session that we took last time. So if you want to revisit that and look at the network capabilities that we talked about, I encourage you to do that. Very, very beneficial as well. And then obviously we have Google have a security culture, which I referred to already, for all employees, for keeping their devices and credentials safe. They got procedures and best practices to follow. And obviously, before anyone joins and go into a data center, they will have obviously get a background check as much as the allowed by the law. And the other part is, of course, all the employees get trained on security and best practices. So there are procedures to follow, and Google encourage that as well. Obviously, GCP, like I said, is designed for security. So kind of now we have a feeling of a high level of security implemented, how it is baked into the Google infrastructure. Google Cloud benefits from running on top of this secure Google infrastructure. So you can see that Google Cloud is designed for security to the core as well. So it's like the DNA of the services. So when Google design new service, the security is not an afterthought, is the first thing they do think about. So they think about VPC network security. So when they design network, the network is, they are logically isolated, control public internet ingress and egress traffic via firewalls. So we will talk about firewall rules. And then they've got monitoring. So monitoring, there's like a suite of products that will help to monitor what's happening with the network, with the security, with access. So diagnostic with that, kind of in-depth diagnostics with can be done with that. So these kind of tools that help us to do that. And from regulatory compliance, obviously Google, they've got a very large list of compliance standards, security standards that they follow for different industries. So I think there is a link here to just to check all those to that satisfy the different industries, whether it's financial, whether it's health, whether, so they've got kind of these certifications that satisfy different industries and different requirements. So that's from a regulatory perspective. Then we've got this shared security model. So this is very important. So now kind of have an overview of security in Google. We will talk for a minute or two about the shared security model. So when we are in an on-premises data center, the customer will be kind of taking care of the security stack end to end, from basically the data center itself, from the building itself to the hardware, to the software, to the applications. They will looking after everything, which is a lot to think about. When you move to Google Cloud, security will become a shared responsibility between you as a customer, a customer of Google Cloud, and Google as a provider. So in this case, we're talking about things that Google look after, which will be thinking about as security of the cloud, which will be responsibility of Google. Things like the data center, the hardware, the infrastructure itself, the network itself, from the bottom layers. So this will be the security of the cloud, will be responsibility of Google. Anything else as a services that you will be using will be your responsibility, depending on which service from Google Cloud are you using. So if you're using infrastructure as a service, something like compute engine, VMs, something like cloud storage, you've got some kind of security that you will need to take care of. Google will take some of the security, like the hardware, the hardware kernel, the encryption, the network, the audit logging, those kind of things, and the building, obviously, that That's basically where these services are hosted. But there is a lot as for you as a customer to take care of. So the operating system, the security of the applications, the data that you put in those services, the upgrades, the patching. This will be all responsibility of the customer. As you move to things like managed services, platform as a service like App Engine, BigQuery, as you move on to software as a service or functions as a service, completely serverless, fully managed services, that responsibility will lessen, and you will go down to how do we access my data? Who should I be giving access to data? And everything else is the responsibility of Google. Now, when we talk, there is a responsibility for the customer of your data and how to do that. Google, they don't leave you on your own on that. They give you the tools to be able to do that. Things like access, identity and access management to give roles to users, permissions to users, and also they give you all the services, they protect all the layers of security, they give you best practices to follow, and so they will help you with that bit as well. So data access, obviously you must control who have access to your data. At the end of the day, it has to be an authenticated call in order to access things like storage services, like cloud storage. And for that, you will need to have some kind of permissions to do that. And Cloud IAM, Cloud Identity Access Management, will be helping you to do that. Access control list that we talked about last time. Firewall rules for VMs in order to access that. So if you have data on your VMs, this is how you control that. And then security assessment. So you will be able to use tools like Cloud Security Scanner for SETI security. Those kind of things that will help you to audit your security on your cloud environments. You can do your own penetration testing, and Google don't require a notification from you, but you need to look at things like terms of service, because you don't want to violate those terms of service. You need to read them so you are in line. When you do those penetration testing, you're not breaking any of those requirements that Google have set in those terms of service. And then you've got many threats that Google have are mitigating by default. Things like Google Cloud load balancers, they mitigate against DDoS attacks. You've got Cloud Armor as well, help you to block access from on a regional basis, or you can whitelist, blacklist. So a lot of things that are taken care of by Google for you, and they give you all the services and other tools that help you to do that. And the scale of the instruction makes a huge difference. So simply because, and this is kind of a very great quote by Dr. Damien, DDoS defense at Google. So he says that absorbing the largest attacks requires the bandwidth needed to watch 500,000 YouTube videos at the same time in HD, in high definition. Well, obviously, at Google, that can be possible inside Google. So they have the instructor that can do that, and therefore they can absorb those attacks because the scale of the infrastructure they have. So it will be nearly impossible to overload the Google network, basically. So denial of service come by default with services like the HTTP load balancers. They've got built-in defense with that, so you don't have to configure anything like that. So you don't need any other configuration. So it's already built in. Things that come with the HTTP load balancer, so it will only accept HTTP traffic. Anything that is garbage, that is not HTTP, get rejected at the edge of the network, at the load balancer level. And there is tools like Cloud Armor that will help you, like I said, to put another layer of security to prohibit regional access. You can block complete countries from accessing your environment. You can whitelist, blacklist range of IPs. So there's a lot you can do with Cloud Armor as a service with security. Physical security, obviously, this is kind of taken care of by Google. They look after their data centers. Everything is monitored. Everything is recorded with cameras. All the activities are recorded. not every Googler can get us to access data centers. So less than 1% of the Googlers will ever have the chance to visit the data centers. And data access security, data at rest, so the encryption at rest. So you can let Google manage all the encryption for you. You can bring your encryption keys. You can let Google manage that. So you can store the encryption keys completely outside Google, which is called customer supplied keys. But if you lose them, basically you are on your own. Google won't help you to decrypt. So anything that is stored outside, it will be your responsibility. And then data access security, data in transit. So again, all the data is automatically encrypted when it's sent basically in the boundaries of Google. But then anything that is outside, that you send outside, then it will be, it depends where you're sending it. So there is kind of a shared responsibility there of how to encrypt that data, that communication, if it's outside Google. And then server and server stack security. This is, again, from the hardware perspective, Google provide what is called the Titan security chip on their servers. So they can do trusted server boots. So anything that is not trusted. That's basically to make sure that the software are basically good enough to be booted on. There is no issues with the booting to a software. It will be completely protected. CPU hardware vulnerabilities. So again, because Google, they use their own hardware, they don't rely on third parties about the CPUs. So again, there was in 2018 there was a major CPU vulnerabilities that affected a lot of companies, Google and their customers. They went about their business as if nothing happened. It didn't impact them at all, and this is because they all use their own hardware and they take care of that as well. Data disposal, we mentioned that before. So if you delete data for Google within maximum of 180 days, as soon as you delete the data, you lose access to it, but it will be basically having that workflow to work within 180 days and in accordance with applicable laws. So it will be basically deleted from all the backups and completely destroyed after the 180 days. And then there is something called access transparency logs. So and this is kind of something new, and it always goes to cloud customers. They always ask, when do I access my data? How will I know if somebody from Google have access? And Google basically they give you that capability to access transparency logs, just to see if any Googler have access your data. So you will have the logs that are specific for that as well. And they basically you'll be accessing them different than any other logs, because the access of the data is done differently than the normal access, and you can get a real-time oversight of that as well. Exporting data, so there are many things to export data with. There are kind of data can be exported from. If you want to leave Google, you can leave without any penalty, but to export your data, you will be charged for egress. So if you export in that, so the standard egress charges will apply with that. And access approval. So access approval. So if you have any issues and you require a Googler or an engineering team to access your data, or they need to access your data, there is an approval API. So you need to approve them to be able to access your data, and then it will be basically you give them explicit approval, and then basically it will be recorded in those transparency logs. It will be set at the project level. Those messages can be sent via email or PubSub, and the approval will be done through the Google Cloud Console. So this is all about access approval. So there are situations where Google don't ask you for that approval, and this is because if there is kind of regularity requirements from government to access some data, or something is very kind of seriously wrong with the services, so something is completely broken on Google Cloud and I need to fix it, they won't be able to. They won't wait for your permission, but everything will be tracked in the transparency logs. One of the things that we can Google give you as a tool to manage security is Cloud IAM. So Cloud IAM is all about who can do what on which resource. So that at the resource manager, which deals with the resource hierarchy that we covered last time. I'm going to talk about it briefly here. IAM roles, what are the policies, things that Google give you some tools to help you with those roles that you give into your groups and users. They give you a troubleshooter tool as well. And you have obviously with that audit logs. So you can see who have access to what. So you can track that as well. And then there are some best practices that we're gonna talk about. So a resource manager is about managing those resources. So what are kind of resources we have in GCP? So it's all about who can do what on which resource. So the who could be me and you, could be a group of users, could be a cloud identity, it could be a Google group, it could be somebody with a Google account, basically. And then on which resource, basically those are can do what basically is the actions, the permissions that are required to allow them to do a particular task. And then it needs to be applied to a resource. So it could be a VM, it could be cloud storage, could be anything on Google. So this is kind of a policy. It's basically a binding of a member and a role, which basically is a set of permissions, and then on the resource. And the resource could be in the resource hierarchy. I can apply it at the organization level, which is basically an organization of a G Suite identity or a cloud identity. So this is your organization. So, and that organization will contain folders. Folders could represent things like departments, could be representing teams. So you have a segregation of your environment into different folders, and then I can create projects underneath, and then inside the project, the level where I can create resources. So all my resources will have to exist in those projects, and then I can give access to members and give them those roles at any of those levels in the hierarchy. So this is organization level, the folders, and then the folders offer that flexible management, basically. So I can go create my departments, as I said, and then I create the project where I can create resources, I can track the resource access, I can enable billing. This is why I get billed for my resources, and I manage permissions and credentials at that level. And I enable also the services and the APIs at that level as well. Members, like I said, they can be any Google account, it can be Gmail accounts, they can be the complete organization. I can give access at that level. And then users and groups in cloud identity as well. Obviously, those users and groups, we don't create them on the console, we create them in the workspace. And then this is kind of really kind of a powerful feature in here, because they are completely segregated on from the GCP console. So I don't have to worry about authentication. The authentication will be taken care of by Workspace, which was known before as the G Suite. So those roles, as I said, it's just a set of permissions, and we've got, and then when I set a permission, it's basically when I set a permission, those set permission, it's a collection. That collection is a role, and I can give a role to those members that are specified. Another specific member that is also very useful in GCP is what is known service accounts. So service accounts is what allows me to do server-to-server interactions. It will allow me for a VM, for example, to be able to have a role. So it takes the identity of a service account. So it doesn't matter who's accessing that VM. That VM, if an application is running on it, if that service account got some permissions, that application will be able to do those tasks as per the permissions of that role that I've given to that service account. So I can assign that to that, and I will be able to take the identity of that. The VM will take an identity of a service account. And there are two types of that. Some of them, they can be Google managed. So Google will take care of all that. They will take care of the keys, the rotation, or the user managed service accounts, where I will be responsible as a user to rotate to store the public portion of the user managed key, responsible for the private key. I can the rotation of the keys. So I will be taking care from that perspective. And the Google managed, obviously everything is managed by Google for that instance. Remember, Google does not save your user managed private keys. So if you lose them, again, very important, Google won't be able to help you to decrypt any of your data. So just be mindful of that. The thing that comes with using your own user managed keys. And if you want to see the list of keys associated with the service account, a simple gcloud command will allow you to do that. Labels is another one that help you to manage your cloud instances. So you can put labels for many reasons. You can um, use labels to segregate and do granular billing in different for different environments, for different teams, as long as you label the resources with a key pair for key pair values. So you will be able to do that granular billing at that. You can do stages, you can do components, you can do state. So you can say, for example, a VM, if it's ready to be deleted, you can label that. So programmatically, you can set up a workflow to automatically delete VMs if they are ready for deletion. And you can separate and distinguish between VMs by using labels on them. Okay, many of the services, they use labels. There are some of them, they don't support labels. Documentation is your best friend to find out what are those. IAM roles, so what kind of IAM roles do we have? We talked about that in the last session. 3 types of role. We've got primitive, predefined, and custom. So the primitive ones, they apply at a project level, and this is where they are very kind of broad. So the primitive roles, you have a viewer, an editor, you will have an owner. So an owner of a project will have ownership of all the services on a project. An editor role will have an editor role on all the services. And you will have a viewer role, which basically you have read only on all resources. Predefined roles, so these are more of a you can use them in a production environment. They will be more specific for the services. So each service on GCP, like BigQuery, cloud storage, they will come with a predefined roles that Google have created with a set of permissions. And based on that permissions, the user can use to use particular tasks. Custom ones, basically, if you want to be more granular. So if you see that the predefined roles have got more permissions of what you need from a security perspective, you don't want to give all the separate permissions, you can create a custom role from predefined role and select only those permissions that you need as part of that role, and you can basically give it to someone to use it. So primitive roles on all resources, owner, editor, and viewer. And then we got predefined roles, so they are specific. You can find predefined roles for different services, and then from that you can create custom roles. So you can remove some of those permissions from the predefined role, and you create that custom role, and then they become a policy. So a policy is basically a binding between a member, a role, and give it to a resource. And you can apply it at any level of the hierarchy, at the organization level, at the folder level, project level, or the other resources. And two or three things that you need to be mindful of here is basically the inheritance is from top to bottom. So all the child components or services, they will inherit permission from the top level. So if I set a permission at the top level, it will be trickled down to all the services. And the other thing is, if I've got a conflicting policies or permissions between a parent and child, it will be the less restrictive policy at the parent level. So if I give at the folder level, for example, an owner for a particular group or a user, and then I give read only for a bucket, then owner will take precedence. It will override the other permissions. So there is no concept as well of deny access. So I can't break that inheritance at a lower level by giving deny. In GCP, you either give permission as part of that role, or you don't give anything. So these are kind of 3 things you need to be mindful of here. And then there are other things which are called organization policies. Organization policies will allow you to do some constraints at a high level. So if I want, for example, from all my VMs, for example, in my organization, not to be able to SSH, then what I can do, I can set a constraint at organization level and say no SSH at the organization level. If I get a chance at the end, I will show these features from the console just to have an idea about that. So these are the constraints, for example, disable VM serial port access, disable service account creation, disable trusted image project. So there's many kind of constraints you can set at the organization level or the folder level, and it will, again, it will trickle down, it will be inherited all the projects underneath. The IAM recommender, so the IAM recommender basically works after with at the back of machine learning algorithms that run on GCP, and basically what they do, they will look at the profile of a role that's been used for 90 days. And as I said, the role is a set of permissions, and basically on the frequency of use of those permissions, Google will say we come with a recommendation. So if a role has got, like, let's say 50 permissions, and we've got about 15 never been used, it come with a recommendation saying, hey, actually 15 permissions haven't been used, so we recommend you to use a custom role that will remove those permissions for you. So it doesn't action that for you, so it will give you the possibility to look at that recommendation, and it will be up to you to accept that, and will apply it, and it will be applied for you if you accept to take that recommendation. So there are kind of three types. You can revoke an existing role that you haven't been used, or replace it, or add permissions to an existing role. So let's say from your profile, the ways that you've been accessing the resources, it will come up, okay, we think as part of that machine learning algorithm that you will need these extra permissions. So it will give you that recommendation as well. And then what you will see, I will show you on the console, you will see like a bulb, an icon, and it will basically see if you can apply or dismiss that. And then the troubleshooters. Troubleshooter is another tool that will allow you to see if you have any issues with your roles. So you will be using it from the console, and you will examine your IAM policies that apply to resources, and you will see what is the issue of a particular policy that you are applied. And the maximum effectiveness required a security reviewer. So you need to give that IAM security reviewer role in order to use the IAM troubleshooter. You can use the Cloud Console, the G Cloud, or you can use the RESTful APIs to do something more programmatic approach. But obviously, the console is the easiest way to have a look at that as well. And then IAM audit logs. Obviously, for access, you will have to see who've accessed my data from administrative activity, who's done something, who's removed the user, who've get access to something. So the admin activity logs, they are actually enabled by default. They're available for 500 days. You don't pay for them, and you can't disable them. Data access audit logs, they are disabled by default because they incur charges if you enable them. They will be retained for 30 days. Basically, those audit logs, they give you who've accessed your data, not from administrative perspective, but who've accessed your data from cloud storage, for example, or from your VM or things like that. And then there are also some other system event logs, which are basically to do with the system activities. So let's say Google are doing some kind of host maintenance, and they need to migrate VMs to different hosts. This is where this can get recorded. They are free. They are enabled by default. They are available, retained for 400 days. So these are kind of spoken about now. So this is just like summary for those. And then from IAM best practices, things that you're going to see across the board is principle of least privilege. So just give the minimum that the user can do that job. So, and this is basically leans towards use custom roles. So use custom roles with the exact permissions that are required. If a predefined role, it does the job for you, and it's not giving more what is expected, use them. But the idea here is never use basic roles that gives you broad range access to projects. Assign roles to groups instead of individual users. So when you are in workspace, create groups for different teams, for big data or database management team, for security team, for networking team. And then this is where you add users. And then you apply the roles to the groups. So if somebody is new, you can add them to the group, and they will inherit those permissions. If they leave the company, you just leave from workspace, you remove them from that group, and they lose all the access to Google Cloud. And this is what the beauty about segregating those two and not having users added into GCP. Custom roles, to be mindful of, they're not maintained by Google. So you are creating those custom roles from predefined roles. So predefined roles are completely managed and maintained by Google. If they add some permissions to them, they will manage them themselves. But the custom roles that you create it's your responsibility to, if something changed on the predefined roles, you will have to go to there and customize them and add those permissions yourself. Obviously, audit logs, audit policy changes, always be mindful of that. Look at the audit logs and set them at project level. And basically always do regular viewing and auditing of your logs to check those permissions and audit policies. Okay, so this is from the tools that Google gave us to have access. VPC, the network itself, there are things that we need to look at. So one thing is firewall rules. So the firewall rules in GCP, they apply at the network level. So last time when we talked about networking, we said the VPC network is different than all the cloud providers. There is massive capabilities, massive differences in the sense that the VPC, the network when we create it in GCP, it's a global resource. So and the firewall rules, they are allocated to networks, and they do apply at the instance level. So the calculation of the network of the firewall rule, even though the firewall rule we created associated with the network, but it does apply to the VM inside of that network. So, and you've got capabilities on where to apply those, either all the VMs in my network, or I can specify tags. So when I create a VM, I can say, okay, this is a front-end server, and the firewall rule that I will be creating, it's tagged with front end. So it will basically apply that rule to that VM. Or I can basically use what is called service accounts. So the VMs that I created with service accounts, I can say all those VMs that are under that service account, I apply that firewall rule to. The firewall rules are stateful, which means that for each initiated connection, that traffic is allowed in one direction. As long as that connection is happening and is valid and is active, the return traffic will happen, even if there is a firewall rule in the other direction that says deny. So as long as I've got one, I will have the reverse connection happening. So this is a bi-directional communication once a session is established. A session is established on its active, it's considered active if at least one packet is sent every 10 minutes. So we will have a look in the console how to create a firewall rules. It's basically direction, source and destination, protocol, action, allow or deny, and there is a priority that goes with that. There are some implied firewall rules that are part of the VPC when we create it, and there are some default VPC firewall rules that basically we can use, or we can just change or don't use them and override them. So things like allowing SSH, allowing RDP, SAMP, things like that. So VPC network traffic is always blocked. This table will show us by default what is everything blocked. We can't change that. Things like GRE traffic, egress traffic to SMTP, protocols other than TCP, UDP, ISMP, and IIP and IP. So this is just to protect your project of being a spam server, for example, to SMTP. So that's already a block. Again, from best practices, least privilege, minimize direct exposure. So use only ports that are required, traffic that is required. So this kind of things that comes as the best practice for firewall rules as well. There is load balancing as well. So you can use what is called SSL policies that are supported. The default now is not as the slide said, but it's 1.3. So in Google, we've got profiles. So profiles of SSL policies. There are 3 managed SSL profiles. You've got compatible, which basically allow the broadest set of clients, include those which support out-of-date SSLs. So this is like the most flexible one. And then you've got modern, which basically supports a wide set of SSL features, allowing modern clients to negotiate SSL. And then you've got restricted. So this kind of supports a reduced set of SSL features intended to meet stricter compliance for requirements. And you can create a custom one. So you can basically, in that sense, specify the exact SSL features that you require. If nothing is selected, the default profile is applied, which is the compatible profile. The other one is best practices for VPC. So don't use default network. Default network will create a subnet for you across the globe. You want to be using custom, basically, and be in control where to create your subnet. And any VMs that are need to communicate with each other, put them in the same network. Anything that don't really talk to each other, segregate them. So you've got this isolation of VPCs, and then obviously use load balancing with SSL policies always in front of web service, which actually does completely make sense. We've got things like private Google API access. So the private Google API access, basically what it allows you to do is any VM with internal IP. You don't need a public IP to basically access the Google services, public services like BigQuery, like Google storage buckets. So this feature, it applies at a subnet level. So any subnet with private Google access enabled will be able to access without public IPs. If the subnet is not enabled with private IP with private Google API access, it will require a public external IP in order to access those services. So that's all good when it comes to firewall rules, to control access to VMs, allow traffic or not allow traffic. When it comes to services like BigQuery, so how do we have for managed services to control our access to that? And this is what service controls are about. So service controls basically helps improve your ability to reduce the risk of data exfiltration. So an example of that, let's say you've got a company, you've got a contractor that is working on your data. So let's say you give them admin on a cloud storage bucket inside your project. As soon as you give them admin on that, there is nothing stopping them copying the data to another storage bucket in their own project. So, and this is what with the firewall rules, you won't be able to stop that because firewall rules apply to VMs. So in order to do that, you will be able to do what is called service control. So you create a perimeter around your project to say nothing can leave my project if I decided to not to. So you can use that on BigQuery. So that's basically how you access that. So let me show you a couple of things on the console. First of all, we will have a look at the firewall rules to start with, or give you an idea what's the VPC networks that we talked about earlier first. So if I look at this is GCP security project. This is the default network. So you can see here, it creates for me a subnet in all those regions. So to understand what are regions that we talked from networking perspective last time. So let me show you the Google network as a whole. So this is the map of the Google global network. So you can see here, Google owned their own network, and this is why we said this is very, very powerful. There's over 40% of internet traffic goes over the network. So powerful. From data center perspective, where this Google exists is in all those regions. So you can see here strategically across the globe. So when I create a network on Google Cloud, it will create a subnet for me in those regions. So it will be one network across the globe. Let's say I create a subnet in Sydney and a subnet in, let's say, Las Vegas. I would be able to get those machines to talk to each other by default. I don't have to do anything. So I don't have to worry about routing, the only thing I can control traffic across that is using firewall rules. So the firewall rule will say, do you allow or deny access to traffic to go from that VM to the other VM? So this is when I say we're creating all those subnets in all those regions. So we've got the default network. So not a good practice to use it because it will basically increase the surface of attack from a security perspective. So, and I can't see any company have presence in all of those regions. That's why the best practice is to delete the defaults and create a custom one. So when you create a VPC, you've got two options. You've got the automatic one, which is similar to the defaults. It will create a subnet for you for each of those regions. It will give you those default firewall rules if you want to use them. And you've got some implied rules to allow egress to the internet and deny anything coming from outside to yourself. So best is go to custom. And with custom, I can create subnets in any of those regions I specify. Now, this is the VPC that we talked about last time. So the firewall, so like I said, when I create a firewall rule, if I create a firewall rule here, what I'll say, I give it a name, let's say use demo, and then what I'll do, I select the network. Obviously, I've got only one network here, and then I set a priority. So priority is basically, let's say I've got a set of firewall rules, and one of them is saying they've got the same destination, they got the same source, they're using the same protocols, everything is the same, except for the action. One of them is saying allow, the other one is saying deny. So which one takes precedence? In that case, we will be looking at the priorities. So the highest is the number, the lowest the priority. So if I want to put a firewall rule with the highest priority, I would be starting, for example, at 0. This is the highest priority of the firewalls. So I will be looking, Google Cloud will be looking at the number of the priority and will decide which one will apply. And then I will basically be deciding traffic, ingress or egress, allow or deny. And then I've got targets. So I can say anything in that network, all the VMs. I can say specify targets, tags. I can say the service account. If a VM is created in a service account, only those VMs under that service account will that rule will apply to. And then I can specify the source. So where is this the source IPs that are coming, or source tags for those VMs? And then I decide the protocols and ports. And this is where best practice to use only the protocols that I need for that firewall rule, only the ports that I need, and I can specify other ones. And then I create that, and then it will be applied to the target that I specified in my project for all the VMs or the tags or anything like that. Now, that's all good to control security for my VMs. For the other services, like I said, like BigQuery, cloud storage, I need to put a perimeter around that. And the way that works is, let me show you. So if I go to, sorry, the other thing that I wanted to show you is the policies. So if I go to network services, organizations policies. So to put the constraint on services, so IAM. So if I go to organization policies, so this is like I don't want to SSH to my VMs. I don't want to create service accounts on my, and this is where they are. So there's a loads of them. So in my project, for example, this has been inherited. So I need to have a look at them at organization level. And this is where I can edit them and apply them. So I can change them. So if I want to disable, for example, all IPv6 usage inside my projects, I can do that. Okay, if I define allow external IPs for VM instances, so I can disable that. For example, I don't allow anybody to use public IPs on my VMs. I can customize it. I can deny, for example, and all the VMs in my organization or all my projects won't be able to add public IP addresses, for example. So these are the policies, the constraints that I can set to be able to do that. Now, going back to service controls, that perimeter that I was talking about. So if I go to be setting that, because the firewall rules only apply on VMs, how do I control access to my managed services, serverless services? This is what we call service control. So if I go to security, security. So in here, what I can do, I can set when it comes, which account I'm using here. So I should be good. So what I've got here, I've got what is called Access Context Manager. So in here, I can set some rules. Let me check this one here that I've created earlier. So in here, what we're saying, we're creating a BigQuery, BigQuery region. I want to I want to control access to my BigQuery. Who can have access to my BigQuery? So what I'm saying here, I'm setting a policy here to say regions that are allowed. So I can specify which countries that my users should be coming to be able to use my BigQuery datasets. I put in here, for example, Netherlands in Europe and Maldives. So this is my wish. I wish I had a holiday in Maldives. So this is kind of just to bring a smile to my face while I'm doing this work. So yeah. So if I try to use BigQuery now, so this is if I go to the service controls here. So now I'm setting my perimeter for BigQuery. So if I have a look at this demo here, so what I'm saying here to edit that perimeter here, what I'm saying here, I'm using this in my project. So my project, this one that I'm working on, GCP security, the restricted services that I want to restrict is the BigQuery API. So I want only those users who coming from those regions that are specified to be able to access my BigQuery. So and then I can by default all services on the configured virtual IPs access. This is the private Google access that I said earlier. So I can have anybody, or all the VMs with private IPs can access that. So that's not a problem. Or I can restrict those as part of this perimeter as well if I wanted to. And then for the access level, I'm saying those regions that are specified for BigQuery region, this is what I'm using. So the BigQuery region that are specified in the access context manager. Now, if I want to go to BigQuery, for example, this is my BigQuery here. Now, because I'm based in the UAE, if I try to run this, it's telling me you've got perimeter. You're not coming from the right region, so so you won't be able to use the BigQuery API. So what I have to do is to go back to that access context manager and be able to edit that. And I will need to come back from the Maldives and need to be from UAE. If I save that, then I go to my BigQuery and let's see. Sometimes this needs refreshing. So, okay, what I'm gonna do here, let me compose a new query. I need to, so that BigQuery that I'm gonna be using, I'm gonna run a query on a public data set. It's not time to talk about BigQuery, but just to yeah, so it does take time to propagate. That's new. Okay, it still hasn't propagated that. I've upgraded that policy. But what I can do, I can, instead of waiting for it to happen, I can just delete that, and then I will delete this. So if I go back now, see, even if I've deleted it, it's still okay. Let me close BigQuery and use BigQuery again. Remember, we're dealing with a global service, so those APIs, they are distributed globally, so it does need time, a minute or two to propagate across all the edge points of the Google network. Okay, so now I haven't got any restrictions. So what I can do is, if I want to create those restrictions again, all I need to do is security again. Let me open it in a new tab so I'm not losing this window. Open in a new tab. And it's better to see how we create it actually. So I create my, you do require organization level access. So I select my organization here, GCP MENA. And see, it didn't have even deleted it when I deleted it earlier. So if I go to the service controls, okay, so I still have that rule, but I haven't got the perimeter, so I can use, and this is why it didn't work. So I create the perimeter now. So I give it demo, I select my project, add project, done. Restricted services, the BigQuery API. Okay. I'll leave that default and I'm basically using that access, the BigQuery region. And I can create that perimeter now. So that rule that we've showed you, now it says it is UAE. So if I run that query, it should work in theory. So it's not recognizing that I am in the UAE actually. So let me, no, there you go. So it is. So so now it has propagated. Very it's not consistent. So let me check that access policy here. Well, I'll delete it actually completely. Okay. Delete. Yeah, there's inconsistencies from the previous one, so I need to start it clean. Okay, let's start clean here. So basic mode region. So here we're saying UAE. Okay, give it title, BigQuery. And true. Okay, save that. Create my perimeter here. New demo my project. Restricted services, BigQuery. Add that. Okay, all services, access level. So BigQuery here. Okay. And then I can do more specific things with ingress policy, egress policies. I can even specify the type of device that should be used to be coming to use the API, the operating system, for example, the IP where it's coming from. So all those things I can do in these extra roles. So I can do even sources. I can use the access level like I've set up in the context manager, or I can do from another project. Identity, for example, any user, any identity, any service account, so I can do those as well. So I'm not using any of those just for the simplicity of this demo. So if I create that now, so now the Google API should be able to run from UAE. So I've got the results. I run it again just to make sure we are clean now, set up cleanly in this. It is running without any issues. And then if I change this to different country, And now, because I've changed from different country, that's not allowed now. Okay, and that's what I've got for you today. So, so this is basically we took some of the security things that Google helped us to protect our projects. So the firewall rules, like I said, from perspective of VMs. So they are categorically set at the network level, and but they for any managed services, serverless services like BigQuery, Bigtable, those things that I can't apply firewall rule to, I've got this service perimeter that I can set rules depending on IP addresses, devices that I want to use, regions that I want to come from, operating system for endpoints that are coming. I've got a lot of flexibility to manage service accounts. This is like simple demo of how to do that to basically protect against anything moving data outside my perimeter. So even if I give full access to those resources from cloud IAM roles perspective, nobody would be able to exfiltrate my data outside my perimeter that I put around my projects. And I can do different perimeters if I want to, which is called bridge service controls. So I can get two perimeters to talk to each other. So to add complexity to that. So this is all I've got to you for you in this for this one here. If there is any questions, let me have a look at the chat. Okay, if there is any questions, happy to take them. Otherwise, you can reach out to me with any other information that you want from on this topic, security in Google Cloud. Obviously, 1 hour doesn't do it justice, so try to cover important topics from security perspective. But there is a lot more to it than that. So, so thank you very much for your attention, and thank you for joining us. Again, remind you to register for the YouTube channel, and till next time. Thank you very much, and have a nice rest of the day. Have a nice evening, and see you again. Thank you so much. Thank you. Assalamu alaikum.